A few months ago now, we announced general availability of the new Azure Front Door SKUs, and I'll leave a link to the blog post here. And this was a fairly comprehensive revamp of the service, and it came along with some pretty exciting new security features. I want to zoom in on this video into Azure Private Link support for Front Door, because this is something which is missed fairly often in my experience. And if you're a Microsoft customer, combining Private Link with Front Door lets you do things that you can't do with any other cloud reverse proxy or content delivery service. If we jump to the documentation for Front Door, I assume you're familiar with Front Door if you're watching this video, but effectively it's an edge-hosted reverse proxy with full WAF support. So this runs in one of the hundreds of Microsoft Edge locations around the world. So if you put Front Door in front of your application, then that's going to give you really great performance, because you're almost definitely going to be terminating your connections much closer to your users, and you can deploy your WAF, web application firewall functions at the edge as well. That connection is terminated in the edge, and then generally what happens is you define your backend server, referred to as your origin, in one or more Azure regions. What are we talking about today is when you go from that edge location, so when you enter the Microsoft network at the edge POP, and you talk from the edge POP, that could be, for example, in London, to your origin server, that could be in any Azure region. In this video, I'll have my origin in Sweden. So when you go from London to Sweden, generally the front end to origin communication would happen over public IPs. And that's how it would be done in the past with Front Door. That's how it would be done if you were to use any other external provider talking to your Azure region. But with this Private Link support on Front Door, what I'll show you is that front-end communication from the POP to the Azure region will be completely private. And that's quite powerful, because it means anything that lives in the region, that lives in the VNet, any of your backend web servers, backend load balancer, etc., doesn't need to have a public IP address, and that's quite attractive to certain verticals. I'll also leave a link to the actual documentation on how you get started with this. So the general idea with this video is to sort of take diagrams like this, take documentation like this, bring it to life, show you how it looks and feels, and help you visualize what's happening behind the scenes more to cement it in your brain. A quick refresher on Private Link. If you've just watched the application gateway with Private Link video, then this will be familiar with you. So just to quickly cover it off, Private Link is a service on Azure that uses our SDN for enabling private network communications from things called private endpoints. So private endpoints are NICs in the VNet that let you onboard to Private Link, and then you ride the escalator up to the first floor where you can get out, and you can get out into an Azure PaaS service like Azure Storage, Azure SQL, or you can exit into something called a Private Link service, which is an outbound endpoint in another VNet. And in the previous video, we showed how that could be mapped to Application Gateway now. What I'll show in this video is you can map that Private Link service to a standard load balancer, which maps to your backend like a web server. What is possible now with the new version of Azure Front Door, we can effectively use Private Link to get from Azure Front Door all the way to your service using the chaining of all these various Private Link components. And we will revisit this analogy that I've used for Private Link later in the video to drill home some of the points that we make. Right, a rather simple lab topology to get us going with this one. I've got a web server, 10.8.0.5, listening on port 80, and this is behind a Azure standard load balancer, an internal load balancer, which means it's only got a private front end, which has got the IP address 10.8.0.8, which is also configured with load balancing rules that map in on port 80. It's important to note that I've defined my backend based on NIC, not an IP address. So we can see that if we look into the load balancer config, backend pool is defined based on network interface, not on IP address, and that's a prereq if you want to put the SLB behind the Private Link service, as we'll do in this video. And we can just do some basic tests to get us going. From a virtual machine with reachability to these private IP addresses, you can see that the actual server is reachable on its own private IP. That's the NIC of the VM in Azure. If I go to the IP address of the load balancer, then that also works. Just returning a simple text file hosted on the the Microsoft IIS web server. Okay, the next thing that I've done is map private link service to my Azure standard load balancer. And I'll show you what that looks like in the portal. So I've got my private link service that I've set up here, which is configured in Sweden Central. You can see that it gets an IP address in the VNet. If you go back to this diagram here, all of these components are in the same subnet actually. So whenever traffic comes into my private link service later, you'll see it being sourced from this address. You can add multiple addresses here depending on the scale you're operating at. The next step in this is to leverage this private link service. So to do that, I'm going to go and set up Azure Front Door and show you how that side of it works. You can imagine this is the kind of the provider side. The consumer side in this case is going to be Azure Front Door. I know that when I set up my front door, I want to enable web application firewall, and it will ask me for a policy for that WAF. So, slight interlude, I'm going to show you a new feature of Azure Firewall Manager, which is now the integration and ability to manage your WAF policies from this centralized point. So let's go ahead and make a new WAF policy, and it's for my premium SKU of Azure Front Door. For now, I'll just leave it in detection mode. Now that I know my WAF policy has finished deploying, I'm going to go ahead and create my instance of Front Door. Make sure we choose premium. That's the only SKU that supports the private link feature. You see here that the name that you give it will determine the front door URL that you get. I'm going to choose custom endpoint and just give it a random host name. A host name is not particularly important in this case because Front Door won't be using that host name to resolve any sort of public IP addresses, because the whole point of this is to have a private communication from the Microsoft Edge, where Front Door lives, to my origin that's living inside of my virtual network. Let's go ahead and enable that private link service. At that point, you can either connect to a private link service in your directory, which is what I will do because it's all inside of my single subscription, or if you were going cross-tenant or to someone else's backend origin, you would choose by ID or alias. So I'll choose my private link service, which I set up and shown you before. And this section here for request message, this would be for the administrator and owner of that PLS connection, if they were in a different team, etc. And then I'm going to choose my WAF policy that you saw me set up a second ago. Back over on my provider side, I can see that that inbound request to connect from Front Door to my private link service is pending, so I need to go ahead and approve that. You can also see that in the meantime, my my Azure Front Door is not working. In fact, my backend origin health is 0, and hopefully we'll see that change in a second. Okay, that approval's gone through now, so let's have a check of our setup. Just one thing to mention, when I check my origin settings here in Front Door, you can see that I've got my private link service details, etc. And up here where we entered the host name originally, you can see that this setting here is ticked for enable validation. What this will do is it will compare this host name you've put in here versus the host name returned in the certificate from your origin if you're using HTTPS. Now for me, it doesn't matter what I put in this host name because I'm just testing using HTTP, therefore certificate exchange is not happening, but that's something worth bearing in mind for a production setting. Okay, so if I go into metrics now on my Front Door, you can see now it's at 100%. And in fact, if you go back an hour or so, you'll see it bounce around. This is when I first enabled private link and went through the approval process. So now my backend is healthy. There's a default route sort of behind the scenes here for my origin group, which kind of says, I think coming into this front end, send it to the default origin group, which has got my private link enabled backend in it. So if I go to that Front Door domain that I have there, remember, I need to set my protocol to HTTP, which is what I'm using for testing. You can see that my text file that lives on my web server in Azure is being served up. So let's think about what's actually happening behind the scenes on a diagram. The remote user, which is my browser in this case, goes to this Front Door provided domain name, and depending on where you are in the world, that will be directed to the nearest Front Door POP. So for me in the UK, that's probably going to be somewhere in London, and that's sort of sucked into the Microsoft Edge network in London. Front Door will look at the traffic, apply WAF policies, etc., and then drop down to its routing configuration and go, well, how do I get to the back end? So we've kind of passed through Front Door. We've got the premium SKU as we talked about before. At that point, it goes across the Microsoft backbone from the front door edge, which, as I said, is probably in London for me, all the way to my VNet in Sweden. This is using now private link. So it's gone across the backbone and into my virtual network. And it's entered that private link service. And as we talked about before, that private link service in my VNet is mapped to a Azure Standard Load Balancer, which is mapped to my backend web server, and my backend web server running IIS, and it's hosting that text file. Two things I'd like to point out here. The first one, which is the kind of obvious thing here, nowhere in my VNet have I enabled access from a internet service. This is all using private IPs in my VNet. This is kind of the value proposition of the line for private link. I haven't got a public IP address on my load balancer. I haven't got a public IP address on this object we call private link service. I haven't got a public IP address on the web server. Private link is handling the private communication between edge network in purple here to my origin server inside of my private VNet. And that only happens, of course, once the traffic is inspected and allowed by the WAF on Azure Front Door. The second thing I'd like to point out here, perhaps the eagle-eyed watchers among you would have already spotted this, is in our diagram here, we're missing a component that you normally see in private link designs. And in fact, if we go back to the diagram at the start, what do we not have on our diagram? Right, we have our private link service, which is going to our Azure Standard Load Balancer, which is going to our web server. We have our line called Azure Private Link. We have our front door. But what we haven't talked about is the required entry point to private link, which is a private endpoint. And normally we say this has to be a private IP address in your VNet. But notice on our diagram here, we haven't had to set up a private endpoint. There is no private endpoint in a VNet we manage. And in fact, if we go through the documentation for private link support with front door, you will notice that things referred to here as Azure Front Door private endpoints with dotted lines here. And if you read carefully, it talks about Azure Front Door managed virtual networks. Okay, this starts to give us a clue as to what's happening here. When you set up the binding between your private link service, which you created, and Azure Front Door, when you instantiate that from Azure Front Door, and effectively you instantiate the green line here for private link, to make that happen, in the middle, there's a Microsoft managed VNet, which has got a private endpoint in behind the scenes. So where you place that VNet is very important, right? Because if you set up your integration and you put that private endpoint in a VNet in the US, and you're actually trying to get to a private link service in Sweden, you're going to have a dramatic impact on your latency. And in fact, if we go back to our origin configuration, look down the bottom here, where you have the option to enable private link service, the region that you've picked here is the region where your managed private endpoint gets instantiated. You need to pay attention to the regions within which we support these managed private endpoints for this service to work. Because ideally you want a one-to-one mapping between where your service is and where that managed private endpoint is. So if we sort of round out this diagram and make it accurate from a data plane perspective, reconcile our understanding now with the diagram we created originally, what's actually happening here is when you set up that integration, Azure Front Door in the edge network is talking to that private endpoint in the Microsoft managed VNet. And this is happening entirely using private communications from that private endpoint to your private link service. That sort of traditional private link, which you will be familiar with if you've watched any of the previous videos, that's just standard. Hey, take a private endpoint, use private link to get over here. This feature for AFD being able to consume origins enabled with private link, this is the bit that's enabled the first stage of this. It would be remiss of me not to highlight the fact that indeed private link can be used to get to a private link service into a standard load balancer onwards to a web server, as we've shown in this video so far. But you can also use it, of course, to get to Azure PaaS services. We can put some PaaS services like App Service and Azure Storage behind Azure Front Door for content acceleration, caching at the edge, etc. What I'm going to show you now is, whereas the green line before took us to private link service in our VNet, we can use the same thing to come into Azure Front Door and then use private link to get to one of the PaaS services I mentioned. And in this scenario, we're going to choose Azure Storage. So here's a storage account that I've got, and you can see that inside of one of the containers here, I've got a very simple text file. So I can access that text file just using the standard storage account URL. But what I can also do is put front door in front of that storage account, enable private link, and then disable access to the public front end of storage. What I've just shown there is me coming from my home, going direct into the storage account public front end, but that assumes I'm happy opening storage account to the public internet. So what I've done inside of Azure Front Door is I've changed my origin group, created a storage origin. So I've set origin here to my storage account, and I've enabled private link service. Again, made sure I've chosen a region that's enabled for this feature, and that is in the same region as my storage account, so I get the best performance. I went over to my storage account itself, and inside of the networking settings here, proved the private endpoint connection. What that means is I can now go to my Azure Front Door, copy my Azure Front Door domain, and I can replace my storage account domain, my Azure Front Door domain, and I can still get access to my container there. You see I'm accessing it using sort of the same full URI, but using Front Door. But of course, my storage account is still open to the internet now. So I want to go back into my storage account network settings here and block all access inbound from the public internet. So what I'm doing here effectively is on my storage account, I'm saying, hey, if you're coming in from public internet, then I'm going to deny you, which only leaves the sort of private side of access to the storage account, which must be via an approved private endpoint. So now we should find that the front door access is still working. But if I go back to the container itself and try and access storage account directly now, I'm not authorized to do that. As you can see, what I've done there is the same pattern as before. Used private link in combination with front door to provide a more private network experience. In this case, for website running on Azure Blob, whereas before I did it on a web server hosted in my VNet. Okay, I hope that highlights the difference there between the two scenarios. As usual, there's a few caveats to go through. I was using HTTP in my demonstration, therefore I didn't have to handle things like certificates. For DNS, I was relatively lazy and used the Azure Front Door provided domain name. In reality, you'd be setting up some sort of CNAME and you'd be using HTTPS, so you'd have to deal with certificates and things like that. One thing I'd like to mention, which is a common question in this area, especially if you watched the previous video, is can I chain? Can I put AFD first, go in through private link that gets to app gateway? Is that possible? How would that look in the VNet? Rather than having the standard load balancer there going to my web server, could I kind of come in through front door here, go via private link, go into private link service, and then bounce up to app gateway, as we did in the previous diagram, back down to my web server? Is that possible? Because without private link, chaining AFD and app gateway is a very, very common topology. So is that possible with private link? The answer today is no, it's not possible, but we'll see that at some point in the future. Let's talk a little bit about preserving the original client IP address. In this diagram here, and in fact, whenever you're working with reverse proxies, there's always the question of client IP address. When that request actually comes into your web server and you look at the packet and the source IP address, where's it coming from? Quite often you need the actual client IP address for auditing regulation purposes. If we look into our behavior of our topology here, what we'll see is traffic is actually sourced from an IPv4 perspective from the NAT IP address associated with private link service. We can see that if we jump on the web server, we can see that in the v4 source address is 10809, which is the IP address associated with our private link service inside of this subnet. So all traffic from a layer 3 routing perspective is coming from that IP address. Is that such a problem? Not really. Even when you were using front door without a use of private link, ultimately the v4 address would be an IP address from the back end of front door in the Microsoft Edge network. So it'd be like a 147 address or something like that. So nothing really changes here. It's taken care of in the HTTP headers. Again, we can see that if we look back at the packet on the web server and we go down here into the HTTP section, you'll see here you've got some X-forwarded 4 addresses. You've got the 147 address. That's the X-forwarded 4 IP address of the front door backend. But we've also got here the X-forwarded 4 address of 77.98. If I go to an IP address lookup website, That's my IP address. There's no real additional concerns here when it comes to client IP address preservation. So when you're looking through the private link service documents, you may have come across something called the TCP proxy protocol. And this is just another way embedding source IP address information, but it's not super relevant to us now because we've already inserted Azure Front Door, the reverse proxy, before Private Link even got a hold of the traffic. So we've already embedded the originating client IP address. Last thing to mention would be around if you do use Private Link, just be aware that those IP addresses we configured as part of Private Link service are used for NAT. There are some scale limits associated with it. Each NAT IP gives you 64,000 TCP connections, so depending on scale of your service, you might need more IP addresses. Okay, let's wrap up. When anyone asks me why should I use Front Door over AN other cloud-hosted reverse proxy, if you're a Microsoft customer, then I think about the 4 Ps. There's pricing. If you go from your origin server and you pull data out by a Front Door to serve your customers, that bandwidth's free of charge. The billing commercial side, so if you're an Azure customer, you can use your enterprise commit, etc., to pay for the Front Door service, whereas maybe you would be paying a different provider. So it simplifies the commercial model. There's the provisioning model. All of what I've showed you in this video can be done via code using ARM, the same API layer that you use to provision all of your other Azure resources. And then we've sort of rounded that off in this video by showing you the 4th P, which is private link. And this is the ability to say, hey, I've got a Microsoft component here, I've got a Microsoft component here, I've got an Azure region, I've got Microsoft Edge. I can glue those bits together using private link in a private way, which is just not something you can do if you're an Azure customer using a third-party equivalent to Front Door. So I hope you found that useful. I'll speak to you soon.